Okay, so today we'll be discussing about the core services of Azure Infrastructure as a Service. See, Azure offers hundreds of services, and those services are categorized in different categories. And out of many services, there are four primary services or four core services, which is essential for infrastructure as a service in the cloud. So those four services are here um, called as the computing service, storage service, networking service, and then the um, what to say the uh, security service. So these are all the core services for any cloud infrastructure. And out of the core services, so we'll be discussing the uh, overview of the networking services. Then we'll move on further. So initially speaking about Azure networking services. So the networking services, the name itself says basically it is going to be used for the connectivity. So the networking service itself has four different categories. So basically the connectivity services, application protection services, application delivery services, and network monitoring services. And moving deep into the connectivity services. So basically, the connectivity services are used for connectivity between two virtual networks or connectivity between the cloud virtual network to on-premises or connectivity between two different business account or whatever. Okay, so under the connectivity services, again, we have a bunch of services, including virtual network, express route, VPN gateway, virtual WAN, Azure DNS, Azure Bastion, and virtual network gateway and Azure peering services. So these are all the services which comes under the connectivity services. And our application protection services. So basically, it involves the security. So the application protection services includes the DDoS protection service or web application firewall or Azure firewall or network security groups, service endpoints or Azure private link. So these are all the services comes under the application protection services exclusively for your application security. And further, we also have the application delivery services. So which is basically to deliver your applications in an optimized way. So for which we have the content delivery network or CDN in short, we can call it as. Also, we have Azure front door service and traffic manager, load balancer, and application gateway. And also we have network monitoring services. So basically, whenever you have a network, so network monitoring plays a major role. So where the network activity has to be monitored and the appropriate actions, counter actions has to be taken. So for which here Azure offers four different network monitoring services, which includes the network watcher, express route monitor, Azure monitor, and also virtual network the EAP. And here in this session, so we are going to discuss in detail about the connectivity services. So which is the more core service of Azure Infrastructure as a Service. So the connectivity service here comes with Azure Virtual Network. So Azure Virtual Network is basically a connectivity service, so which is the fundamental building block of the private network in Azure. And also, while creating a virtual network, you need to specify or you need to decide in which location or in which region the virtual network has to be created, and what should be the IP range of the virtual network, and what is the number of subnets the virtual network should have. So all these information you need to define, and also you need to configure or you need to specify in which subscription this virtual network is going to be created or is going to be used. So all these informations has to be given while creating a virtual network. And as I said, the while creating a virtual network, you need to decide what IP range uh, that should be used inside the virtual network. As like in on-premises, you decide what should be the IP range you want to configure for your devices. Similarly, in Azure Virtual Network, uh, you need to specify what IP range has to be used, and the IP range is defined in the CADR block. So I believe most of you would be aware about CADR, that is classless interdomain routing. So where you need to specify the CADR block for your entire VNet, and based on the number of IPs you require within the VNet, you can specify the CADR block size of the VNet. And inside the VNet, you can have multiple subnets created. And for each subnet, what should be the CADR block? What should be the number of IPs required in each subnet? So you can decide on that. You need to configure all those informations. And also, whenever you have a network, security comes into the consideration, or the security comes into the picture. So basically, in your on-premises, if it is a physical network where you may have a firewall to filter the traffic, the inbound traffic and outbound traffic, you may use the firewall to control the traffic. So see, similarly, as like your firewall in on-premises, so here you can have the network security group. Basically, the network security groups are considered as network filters, or you can also call it as a virtual firewall. So using which you can control the traffic. So what traffic should flow inbound, what traffic should flow outbound. So all this you can specify. Maybe a traffic flow within the VNet or between the VNet, between the subnets. All these can be controlled or filtered using the network security group. And uh, we also have the address space, as just before we said, address space. Whenever you create a VNet, you need to specify the IP address range. So that IP address range of the VNet, here it is defined as address space. So while creating the virtual network, you need to specify the address space of the VNet in the CADR block. And basically whatever the address space you specify for your VNet, so in that range all your virtual machines will get the IP address. So basically the first three IP addresses will be reserved for the internal usage, and allowed to uh, st- uh, start using the IP address from the fourth IP of the range whatever you have chose. So again, the subnets, as I said earlier, you can break the bigger network into smaller pieces or smaller networks using the subnetting. So where for the entire VNet, you can have a range of IP. Maybe you may have around 15,000 IPs or 16,000 IPs for your entire VNet. And the big network can be broken into smaller pieces by creating the subnets. And for each subnet you can specify, say example, for my project A, I require only 100 IPs, so for which you can create a small subnet where you may have 100 IPs or 150 IPs. And for project B, I require 200 IPs. So accordingly, you can choose the subnet size. So based on your requirement, you can choose as many, you can create as many subnets, and you can choose the IP range based on the IP's requirement. So it's always recommended to have a smaller subnets, so that it will be easy for you to administrate your network, so that you can also avoid the IP wastage also. And also when you deploy the virtual machine or any resources, so basically you can specify in which subnet the resources should be parked, and in which project the resources should get accessed. So all this can be decided with the uh, configuration of the subnets for that particular resources. And also you can control the traffic, you can control the flow of traffic between your VNet and the internet, or between your VNet and to your on-premises network. So all this is going to be possible with the help of the subnets. And now, so whatever we have understood about the virtual network, so basically we need to be able to compare the virtual network with your on-premises network, so that it will be easy for you to understand, because you peoples are very much comfortable with your on-premises infrastructure. So by comparing your on-premises infrastructure with the cloud infrastructure, so you can easily understand the concepts and the logics. And here, this picture is going to show you about the on-premises network. So where you have your on-premises network connecting to the public internet through a firewall. So where this firewall is going to give the uh, security protection for your on-premises network. So inside your on-premises network, you may have a bunch of servers connecting to your switch, and one cable connecting your firewall through the switch. Basically, in firewall, you'll have three interfaces. One is LAN interface, the other one is WAN interface, and also we'll have one more interface called a DMZ. So DMZ is basically for connecting. It is used for connecting your hosting servers, any servers that is going to be published in the public internet. So those servers will have it in the DMZ. And where any server that should not be accessed from the public internet, or which should not be exposed to the public internet, so those devices will have it in the LAN network. So basically in LAN network, you'll have all your production servers and also your production user network. So where the hosting servers are going to be connected with the DMZ network. Since the LAN network machines should not be exposed to the public network, and where the hosting servers, it should be exposed to the public network. Say if you have a web server or a email server, so those servers should be published to the public network. So obviously, so that should be a screened network. So that's why we used to have the hosting servers in the DMZ. So usually we say the LAN network is a 100% secure network, since it is not exposed to the public internet. But DMZ is a 50% secure network because it is exposed to the public internet. And also we'll have the different IP ranges or IP subnets. We'll have a different IP subnets for your hosting servers. We'll have a different subnets for your production servers. So obviously there won't be any traffic allowed between these two subnets or these two networks. So where if any intruder is compromising any of the machines inside the DMZ, so they will not be able to get access or gain access to the production servers. So that's how we secure our network. And also we allow the production end users, production network users to access the production servers. And also we deny all the external traffic flowing through your LAN network in the firewall. So in firewall, we'll create the rules accordingly, so which will deny all the external traffic flowing through your LAN network, so that your LAN network resources are kept safe. But since you are having the hosting servers, which should be exposed publicly, we used to allow the certain traffic to the hosting servers in the DMZ. So if you are hosting a web server, you can allow port 880 or 443. If you have an FTP server, you can allow port 21. If you have an email server, you can allow port 25. And if you have a terminal server, you can allow port 3389. So based on whatever the servers you are publishing, so the respective ports are opened in the firewall. So we configure the NAT rule so that only the respective traffic is allowed to the respective servers. So basically, this is how you'll have the control in your on-premises. I believe everyone will be comfortable with this explanation of your on-premises infrastructure. If there is any questions or any doubts related to the understanding of on-premises network, please let me know. I'm waiting for your response. Everyone, I'm waiting for your response.
Yeah, we are comfortable, pretty comfortable. So we
Okay,
are,
okay, that's great. So
yeah, we
now,
are really expertise in, I mean, in the on-premises right now. Yeah.
okay, that's great. So now we need to compare this on-premises setup with our cloud network. So basically, whatever the control you have in your on-premises, the similar kind of control we should be able to have in cloud also. Otherwise, there is no point of getting into the cloud. And here, speaking about virtual network. So this virtual network is equivalent to your LAN network with switches and cables. So put together, so here it is called as a virtual network. So this virtual network is basically a private network inside the cloud, as like you have your on-premises private network. Similarly, here we too have the private network inside the cloud. And while creating the VNet, as I said earlier, you need to specify the CAD or range for your VNet. So based on the uh, range you define for your virtual network, so your virtual machines will get the IP address accordingly. As like you have multiple subnets in your on-premises, similarly in cloud in VNet, inside VNet also you can have multiple subnets. So you may have one subnet for having your production servers. You may have another subnet for your hosting servers, and the subnet names you can define whatever the name you want. So for understanding purpose, I just gave the name as public subnet and private subnet. So basically any virtual machines that is available in the public subnet, so that can be accessed from the public internet, so based on the rules configured. And also the private subnet computers that cannot be directly accessed from the public internet, again based on the security configurations. So
Uh, there is a
yeah.
question. Yeah. So in case regarding to the private subnet, let's say I have few servers hosted in my private subnet. So if I want to access that particular service from the outside interface,
Mhm.
will it be possible to create rules like that to access to this specific private
Yes,
subnet?
yes, you can. Yes, you can.
Mhm.
See, but there is no point of accessing the private subnet devices directly from the public internet. As like if you have your production servers in your on-premises, will
Yeah,
you allow these servers to be accessed from the public internet? You will not.
not yeah. We are not
So
doing.
if in case if you want to perform any remote activities, so what you will do usually, you'll have a bastion host in your DMZ. Basically from the external network you will connect to the bastion host, and from there you will connect the remote session of the internal servers, right?
Yeah, it looks like it's like some jump servers
Yeah,
confirmation.
just something like jump servers.
Okay.
So in the same way, you can have a jump server in the public subnet. So connect to the jump server. From there, you connect the private subnet devices.
Okay.
So that would be the optimal configuration. Got it?
Yeah, got it.
See, technically allowing the access to the private subnet computers from the public internet is possible, but it is not the right way of configuration.
Like what my understanding, let
Hmm.
me explain. Like as per like public subnet. So what are the hosted services that we are having in on premises? We can
Hmm.
host in the public subnets.
Correct,
Which
correct,
can be accessible from the internet side. So
correct,
what are the private subnets which is we are having for the production server that should be hosted, that should be configured in the only private subnet areas. That
correct,
should
correct,
be
correct,
exposed to the internet facing.
correct.
So if
And
we
basically, these private subnet computers should be accessible only to your production users, not to any other users or to any other network.
yeah, that's
Got it? Okay. So if there is any more questions, please let me know. Okay, fine. And basically, when you speak about the machines or virtual machines that is available in the public subnet, and these virtual machines will have the public IP. So using this public IP, the virtual machines can be accessed from the public internet. But speaking about the private subnet virtual machines, so which will not have the public IP, so which cannot be accessed from the public internet directly. So then how these machines is going to be accessed from the production network? So basically the production network users will not have access to the private subnet. But basically our production users should have access to the private subnet devices. So basically for which you need to establish VPN connection. Once VPN is been established between private subnet of your VNet to your on-premises production network, so then the production users will be able to access the resources of the private subnet of VNet. Is that clear? If there is any more questions, please let me know.
Basically, how much speed we are can able to get using the VPN between the Android and the
So that is basically based on your WAN link connectivity, and then from the cloud end, the capacity of the network you are choosing. Say example, from your server that is in the cloud network, you are choosing 1 gig as the capacity. In on premises, you have a WAN link with 100 Mbps. So obviously, you're going to you're going to get access with 100 Mbps. So based on your WAN link connectivity's capacity, you can have the bandwidth, and obviously the performance is going to vary accordingly. Clear? Was your question answered?
what is the maximum speed we can get from the Azure?
Okay. Okay. I believe you can get around 20 gig. I'm not exactly sure. Just when we are doing our labs, we can verify that.
Okay.
Okay. So I believe it is 20 gig. Okay. Any more questions? Okay. So if there is no more questions, we can proceed further. Understanding about Azure Virtual Network IP addresses. So basically, Azure offers three type of IP addresses. One is the private IP address. Another one is public IP address. And the private IP address, basically, your virtual machines will have its own internal IP address. So when you create any virtual machine, so each virtual machine will get the IP address from the range of the subnet CADR block. So each virtual machine will get the IP address. So these IP address is basically called as the private IP address. So these IP address can be used for internal communication. So using this IP address, virtual machines within the subnet can communicate each other, or between the subnet they can communicate each other. But these IP addresses cannot be used for accessing these virtual machines from any other network outside the VNet. And maybe if you want your virtual machines to be accessed from the public internet, see if it is an on-premises network, so obviously you need to have internet connection. So through which your machines can be accessed from the public internet. Similarly, so here when you create a virtual machine, so this virtual machine should have the internet connection. So to provide internet access to the virtual machine, Azure offers a service called cloud service. So basically, when you create a virtual machine, along with the virtual machine, this cloud service will also be created. So basically, this cloud service is a service which can offer or which can provide internet access to the virtual machine. So any virtual machine which is created along with the cloud service, so that will provide access, provide public internet access to the virtual machines. For a while, you consider this cloud service is like your broadband router. I believe you might have better understanding about a broadband router. Basically, it will have two interfaces. One interface will be connecting the internet service provider's cable. Another interface, that is the LAN interface, so that can be used to connect your internal devices, maybe your desktop or a laptop. So whenever you have a broadband router, one end connecting to the ISP's cable. So that is basically the WAN interface. And the other interface, that is the LAN interface connecting your laptop or a desktop. And first of all, speaking about the WAN interface, does your WAN interface has a public IP? That is, you have hopefully most of you will have a broadband connection at your home. Does your broadband connection has public IP or not? I'm expecting your response.
Yeah, it's having a
Sorry,
public IP.
I think your voice is breaking. Does your broadband device has the public IP or not?
Yeah, it has.
Okay, can you tell me what is your public IP? Can you check right now and can you let me know your public IP?
103.163.248.244.
That's great. And when you uh, power off your broadband device and then when you power it on, will you get the same IP or the IP will change?
IP will change.
So basically your broadband device is getting dynamic IP address. So every time you power on the broadband device, the new it will get a new IP. Similarly, this cloud service you can understand similar like your broadband device. So every time when you power on the virtual machine, so this cloud service will get a new IP address, which we call it as the virtual IP address. So basically this is the public dynamic IP address. So every time you power on the virtual machine, so you'll get a new public IP address. So since this is a dynamic public IP address, so every time you power on, you get a new IP address. So that cannot be used for hosting your services. When you have a web server, the public IP cannot change every time. So you should have a static public IP address. So in that case, what we can do is we can reserve this public IP address so that this public IP can stay permanent, and this can be used, this public IP can be used to access this virtual machine anywhere from the public internet. So basically the public IP, the reserved public IP, Azure offers first 20 IPs free of cost, and additional 20 from the 21st IP onwards. So you're going to be charged additionally for the public IP. And as I said earlier, anyone can access this virtual machine using the public IP. If anyone is able to access my virtual machine using this public IP, obviously there is a security constraint. So that should be avoided. So where we are going to introduce another component called network security group. So as like you have a firewall in your on premises, so here in cloud, we are going to have the network security group. So network security group is a network filter or a virtual firewall. So where you can control the inbound traffic and outbound traffic. So where you can define the rules, what traffic should be allowed inbound and what traffic should be allowed outbound. And here in this example, I'm allowing port 80 inbound. So which means that all HTTP inbound traffic will be allowed to this machine. And any other traffic, any FTP traffic or any terminal service traffic, so those traffics will be denied. Only the HTTP inbound traffic will be allowed. So in this way, you can securely publish your services or the servers in the public internet.
I
Is
have a
that,
question.
sorry?
I have a question.
Please.
Here, if I want to restrict my remote desktop communications for the public
Mm.
hosted web servers, so how could I do that?
See, basically what you can do is you can restrict all the traffics. You can write a rule. By default, there will be a rule which will be denying all the traffic flowing inbound to this particular target.
Okay.
And out of that, I'm creating one additional rule to allow certain traffic alone. I'm just creating a rule to allow only HTTP traffic alone. So which means that only HTTP traffic is allowed inbound and all the other traffics are denied by default.
Okay. So if I want to, as administrator, if I want to do some operational task inside the server, so
Hmm.
how can I connect them? It should be through the private subnet or can
Sorry, I
so
think your voice is not clear. Can you
yeah,
please repeat your?
yeah, as an administrator, if I
Hmm,
want to do, if I want to perform some operations on the VMs,
hmm,
that
hmm,
hosted VMs,
hmm.
so how could I connect?
So basically, you need to allow RDP session inbound. That is one option. Otherwise, you don't want to allow the RDP session of the web server, but still you may have a jump server inside your network. So jump server or your bastion host server. So basically these jump servers are used to connect the remote desktop session of your internal servers. So basically first we'll connect to the jump server. Once you are connected to the jump server, from there you can use the private IP to connect the web server using the remote desktop session, and you can do your remote operations.
Okay, got it. Yeah.
Okay. Any more questions? Okay. So, and that is going to be the end of our session for today. And maybe in the next session, we'll be starting with creating the virtual network. And after creating the virtual network, we'll be discussing the rest of the topics. In meanwhile, if you have any more questions, please let me know.
In hi, actually, as per my understanding in the on-premises,
Hmm,
so let's say we have different services, applications
hmm,
made up
hmm,
like the different subnets. Let's say
hmm,
we have tier three
hmm,
services, let's
hmm,
web applications and
hmm,
applications
hmm,
and database servers. So in that
hmm,
case, we
hmm,
will be having different subnets, three subnets as well, right?
hmm,
So
hmm,
like considering the on-premises. So
hmm.
will it be possible? Can we do same
Yes,
scenario?
you can. Yes, you can. You can have as many subnets you require.
So we can split, like if I want to use only five
Yes,
IPs for five IPs, which is contains the subnet, or one dedicated
correct,
for the servers,
correct, correct.
like
You
that,
can. You can have
we
it.
can create a segment like that, right?
Yes, you can.
Yeah.
Okay. And any more questions, please? Okay. So if there is no more questions, and this is going to be the end of today's session, and we'll discuss the remaining topics in the next session. Until then, bye bye.